Hello everyone. We have Pre-Calc Lesson 64, the complex plane, polar form of a complex numbers, and sum and products of complex numbers. We've talked about complex numbers before, their general form being a plus bi, but now we're going to talk about graphing them. We graph it on the complex plane. We also call it the Argand plane. You don't need to know that. And what we're doing is we're graphing complex numbers on the rectangular coordinate system, which is the xy axes that we've always known. But this time, the x-axis is going to represent the real part, and the y-axis represents the imaginary part. So if we have this example, negative 2 minus 4i, that equates to negative 2i hat minus 4j hat. Right, so we're going to equate it to rectangular coordinates just like we know. We know rectangular coordinates, we've used them a lot, okay? So this chart gives you a good example. If you have vector form, which is what we're familiar with, if we had 2 root 3i plus 2j hat, that's our rectangular form. And the polar form, we would see it as 430, okay? That's what we're used to seeing. What we're going to see in the complex plane is instead of having I hat and j hat, we just have I. We have 2 root 3 plus 2i, and polar form is 4 cis 30. That's a CIS, okay? Now, what it actually is, the polar form is technically 4 times the cosine of 30 plus I sine of 30, which we abbreviate as cis, okay? So 4 cis 30. And we call this hypotenuse, this 4, is called the absolute value. Okay, so it's some new terminology and some new ways to write things. Okay. What we are going to do is we are going to be converting from polar to rectangular, rectangular to polar in the complex plane. Okay. So determine the polar form of the complex number 1 minus 6i. Okay, so this is related to 1i hat minus 6j hat. We do like we always do. We graph it. We have a positive 1 here and a negative 6, which gives me this point here. Put my 6 here and make this theta. This is my r. I solve for r the same way. R squared is 1 squared plus 6 squared. So r squared is 37, so r is the square root of 37. Okay, I am going to leave it as the square root of 37. There's no need to change it, okay? And theta is the inverse tangent of opposite over adjacent. Now if I do that, make sure that you are in degrees. The inverse tangent of 6 gives me approximately 80.54, but I'm in the fourth quadrant, so I do 360 minus 80.54, and it gives me about 279.46. Okay, so the angle that I have, 279.46, I will now write it as r cis theta. Now you might be asking, why didn't I just write a negative 80? The question gives us these parameters. Theta is in between 0 and 360. Negative 80 is not in those parameters. Okay. Let's do this one. It says find the polar form of 3 minus 4i. Same directions, we're going to have theta be in between 0 and 360. So again, I graph it. I have a positive 3. I have a negative 4. Puts me here. This is 4. That's my 3 theta. Now I know it's a 3, 4, 5 triangle, Pythagorean triple. You don't have to show any work for that. Okay. And we know that theta is the inverse tangent of opposite over adjacent, which gives me about 53.13. Then I do 360 minus 53.13. Gives me 306.87. So I will have 5 cis 306.87. That's the polar form. Now, you might be tempted to write it like this. Okay? That's wrong. They give it to me in complex form, so I have to have my answer in complex form. Okay? All right. Let's do another example. Convert, let's do the opposite way, 6 cis 135 to rectangular. So 135 degrees, right? This is related to this, if it helps you see that better. 135 degrees is here, and it's 45. My r is 6. So I know that x will be r cosine of 45, which I know that the cosine of 45 is root 2 over 2. So it gives me 3 root 2. And I know that it's negative because we're in the second quadrant. And y will be r sine of 45, which again will be 6 times root 2 over 2, which will be a positive root 3 over 2. So now what we used to do is write it like this, with the I hat and j hat, but that is now gone. We write it like this, minus 3 root 2 plus 3 root 2 I. Again, if they give it to me in complex, I give the answer back in complex. Okay, if you weren't comfortable with converting from polar to rectangular before, you need to come into student hours because now we're making it harder. All right, now let's talk about the sums of complex numbers. To sum complex number, you have to add it in rectangular form. Okay, same thing that we did before we had complex numbers. We always convert to rectangular form. Okay, you cannot add it in polar. And you add the real parts and you add the imaginary parts. Okay, the products of complex numbers, if you're in rectangular form, you can just FOIL. And if you're in polar form, you first multiply the absolute values, which is the r value, and then you add the angles. So let me show you. Okay, this first example, we're going to multiply these two. Okay, now, I told you before, if we have cosine 20, I sine 20, I actually can write this as 5 cis of 20 in polar form. I have 6 times cosine 42 plus I sine of 42. This becomes 6 cis 42. Okay? So, I multiply the hypotenuse, or the r, giving me 30 cis, and I add the angles, 30 cis 62. That's all. Unless it says convert to polar, to convert to rectangular, that's all you have to do. Okay, let's look at this next example. Multiply 5 cis 280 times 7 cis 300. So we multiply the hypotenuses, hypotenuse, it's not a term, but that's what I'm making it. So 5 times 7 is 35, and we'll have cis. We add 280 and 300, giving me 580. Now, when you multiply polar in complex polar form, your angle has to be within these parameters, always. So we know 580, right? We'll have gone a full 360, and then we'll have gone all the way over here. We'll have gone 220 past 360. You could also just do 580 minus 360. So this is the same thing as 35 cis 220. Okay? Don't forget, you have to put it in degrees that's less than 360. Okay? So as I said before, you need to be very familiar with your polar and rectangular conversions, because now we've made it harder. Okay, so if you're not familiar, you can go look back on those lessons and practice that now, because we are done with this lesson.